you, Anusha. If you have
Muted.
anything, please feel free to unmute or type. All right. So, okay. Are you able to hear me clearly, Anusha and others? Yes? Hi, Anusha. Are you there? Are you able to hear me?
Unmuted.
Hello? Yes,
Yes? Is my voice clearly audible to you?
yes.
Okay, okay. So please ask questions by typing. That will be better. Okay, because other people will be joining soon. All right.
Okay,
And we will continue our discussion in the usual manner.
okay.
So, do you have any questions for me before we start?
No.
Okay, okay. Did you happen
But
to have a look at the?
chat window is not open still.
It would be open because you are organizer, so you should
Okay,
see the chat window.
okay. Thank you.
Okay, okay. So yes. And yes, also please start the recording in case my system crashes. At least we have a backup.
It is already recording.
Great, great. And all right. So the recording has been started. So whatever screen or the voice is going on will be recorded. And all right. So are you able to see this course page on Big Data Analytics?
Yes.
So did you get a chance to have a look at the quizzes? There are something called quiz here. We have put some quizzes recently, and so please go through these two quizzes. All right, to assess yourself, please go through the quiz. All right, great. So moving ahead. So far we have discussed various aspects of. Let me just go through the discussion from the beginning. All right. So in the beginning, we discussed about what is big data, and then and why big data and other reasoning behind big data. So in very simple words, why do we need distributed computing? And the rest of the things which we are discussing is how of the distributed computing. So all right, let me. So in the beginning, we went through the various aspects of the computing, distributed computing, parallel computing, and then what are the things that become bottleneck and how are those bottlenecks being overcome by the way of various. Hi, Sahab. All right. So, yes. So there is one more person named Sahab in the batch. So that there will be total of four attendees in this class. All right. Now, All right. Now, in the second session, which was yesterday, we talked about two very important aspects of HDFS. Okay, so we went through what is Hadoop, I mean, and then we went through what is HDFS, and we also went through the reasoning behind HDFS, and afterwards, after HDFS, we had gone quickly uh, through the computing. Okay. So I'm wondering where is the. uh, All right. So then we are about to start our. All right, I don't know where it is gone. All right, here we go. It's here. All right, good. So now today we are going to discuss the MapReduce part of it. We talked about yarn and we also, yeah. All right. So yesterday we talked about how do the job tracker and task tracker work. All right. So there's something called job tracker and there are other nodes which are called task trackers. We assign work to the job tracker and that gets passed on to the task trackers by the job tracker. So job tracker assigns the work to various task tracker, observes the task trackers. In case somebody goes down, it reassigns that work to somebody else and then get it done. All right. So here, let me just rearrange things a bit in the on manner which I had planned to. All right. So earlier in case of Hadoop 1.0, the model of computing was only MapReduce. You could only write program in maps and reduces. Okay, and the the only that was the only way you could do computing. But now in Hadoop 2.0, a big change happened. A big change happened, and that change was the MapReduce and Yarn became the two separate things. Okay, while Yarn can execute anything, you give it anything to do, it will get it done through the task trackers. Okay, while MapReduce is just one of the ways of doing things. Okay, under the hood, the operating system remains Yarn. Operating system in terms of getting things executed. All right. So, all right. So, in case of MapReduce, in case of map, earlier in Hadoop 1.0, there was only one way. So MapReduce as well as job tracker, task tracker, everything was in a single component. Therefore, it was not leaving the space for new innovation. The only way people were able to write programs was MapReduce. And MapReduce was obviously not sufficient for every kind of computing. And that's when in Hadoop 2.0, the paradigm and the machinery were separated. MapReduce is just one component as of today, while Yarn remains generic for all kinds of computing. And because of this splitting of Yarn from MapReduce, Yarn became Yarn became the general cluster manager for everybody. Okay. Now, because of Yarn, as of today, the things that run on Yarn is not only MapReduce, but other things, such as the biggest innovation of today's time is Spark. Spark is a really, really fast computing mechanism. And you have HBase, you have Storm, you have Tez, you have Giraffe, you have so it opened the door for all kinds of works instead of only MapReduce. So this is where Hadoop 2.0 happened and Yarn came into picture. Okay, so this is where it opened the door for all of the things. So as of today, we have Yarn and we have MapReduce and we have all these components. So in case somebody likes to write code with respect to Spark, they can go ahead and the things will get done on the same computer using Yarn. Any questions at this point of time? No questions? Shahab and Anusha? All right, all right. There are only two reasons why you will not have questions. Either I am really, really bad teacher or I'm really, really great teacher. So which I believe is neither the case. So you must be having questions. All right, great, great. All right, so yes, I'm happy that you are finding it amazing, Shahab. Let's go ahead. Now, so this was a very quick overview of what is MapReduce. No, I mean, we haven't gotten into MapReduce. We have just talked so far about Yarn, which is the cluster resource manager. Inside Yarn, you have these, the names of components have changed. The things which we talked earlier were a little different, but uh, the names have a little bit changed, but the mechanism is is exactly similar. So let me just pull out one more diagram. I've missed one diagram and I would like to correct that diagram. All right, just give me a second and that'll be okay. Actually, to keep it very, very simple, we have removed a couple of parts from it, but I'm feeling that I should give more description to it. That's why I'm getting into my Hadoop course. All right, I'll just take your one more minute and things will be okay. Just give me 1 minute. I'm just getting some of the diagram right, and that should do the job. All right. All right. Good. So as part of our yarn engine, you have one master node which takes the work from you, which gets the work done from the task tracker everywhere. So I hope everybody got the picture of when we talked about a very simple problem yesterday. The problem was, the first problem we talked about, find a particular line in 200 terabyte of text. Okay. So did that make sense to you, Anusha? Was that example clear to you? And Shahib? All right, great. So every task tracker is given, let's say, task tracker one is having, let's say, if you have 100 task trackers, so task tracker one is having 2 TB data, and and is searching inside those, searching line by line, and then giving the results, right? And similar is the case with Task Tracker 2. Task Tracker 2, I mean, I'll just write a pseudocode for you. For each line in input, if line has my name, whatever is my name, and print line. That's it. So all of these task trackers are executing same code. Okay? All of these task trackers are executing same code. If there is some task tracker 3, okay, some task tracker 3, again, it will be doing the same thing. So this piece of code, which you see here, what this piece of code is doing, it's saying for each line in the input, if line contains my name, then print that particular line. Otherwise, just ignore it. Right? So similarly, when all these task trackers are working parallelly, running the same code, okay, if all these task trackers are doing the same thing parallelly on all the nodes, you will get the results, and then all those results will get saved in another file. Okay, so that was the simplest way of expressing the MapReduce. Okay, so now the question arises that in some cases there could be multiple maps, in some cases there could be multiple situations. Now, one of the mode of getting the work done is MapReduce. In case of MapReduce, we will write two functions. One is called map, other is called reduce. Okay, so that's what we are going to discuss. A little bit more detail if you want. So this is Hadoop 2.0. In this, the job tracker has been renamed to resource manager. Okay, job tracker has been renamed to resource manager, and this resource manager can execute any kind of work. For each kind of work, it creates one application master. For each kind of work, let's say somebody is trying to get the work done in terms of MapReduces, so there'll be a application master on those nodes which will get the work done. So Task Tracker got broken down into three things: node manager, application master, and container. Okay, so every time you want to install a new program on Yarn, you don't have to go to every node and install it. All you do is create a special kind of app master. You create a special kind of app master, hand it over to resource manager and say, hey, this is my app master. Can you execute it on every node? Okay, so app master is a kind of uh, the application master, the guy who gets the work done within that particular application. For MapReduce, we'll have MapReduce application master. For Spark, we will have Spark application master. For HBase, we'll have HBase application master. For Taze, we will have Taze application master. All right. So we will have one application master for each application. All right. So here, this was the previous diagram which we discussed. This was Hadoop 1.0. Okay. This was Hadoop 1.0. Let me just put it here. This was 1.x, as in 1.0, 1.1, whatever you want to call it. So there were lots of clients talking to a job tracker. Then job tracker was getting the task tracker, and this task tracker was only of one kind. This task tracker was MapReduce task tracker, where it was only doing things which were in terms of maps and reduces. Now, need of every kind of new application could be complex, and those things which are so complex cannot be predicted by a generic system. Therefore, Yarn came up with this model. If you want to build your new system, No worries. You write your own application master, give it to resource manager. It will run that application master, and that application master will make sure how its code runs, how the things happen, whether it's MapReduce, whether it's something else. All of those complex problems are taken care by your code. So resource manager and not manager, resource manager is taking care of all the cluster, which machine is free, which machine is busy. All of those complex tasks are taken care of by resource manager, while node manager is responsible for a single node. Node manager knows that how free is particular node, and node manager is the one who creates the space for container, who runs the container, who runs the application master, and application master starts behaving in the way that the architect of that particular application wanted it to. Okay, so this opened the door for lots and lots of application masters, and that's where the real innovation started. So this is the example. This is little complex architecture, but you can remember that it's basically the master guy who is keeping the accounting of which machine is free, which machine is busy, the resource manager, while the node manager is taking care of how many containers it's running, how many application masters are there, and all of that complexity is being absorbed by node manager. Now anything happens in this ecosystem, first the information goes to a resource manager, second the information goes to the node manager. Now node manager has become very flexible because inside container it can run anything. All right, so that's the difference between the Hadoop 1.0. Hadoop 1.0 was very simplified uh, diagram in which there is a job tracker and task tracker. Actually, it's the same thing here also. Now you can see that each application master creates its own container. And in the container, application master asks that, hey, I am MapReduce. I want 5 nodes near this data. So node manager gives that place for execution, and application master gets the work done. And once it gets the work done, it collects the data and saves it. So, okay. So I'm hoping the diagram is clear. So it took me some time to understand the diagram. So I'm hoping that you will find a lot of more questions to ask. No? Node manager has command on node. Yes. So node manager has a complete control on each one node. Yes. An application manager has the complete control or ownership of the application. That's correct, Sahib. All right. So if you want to build a new kind of system, okay, new paradigm of computing, okay, in those case, you will have to create the source code of application master, which you hand over to resource manager, and resource manager you will have to tell that this is my application master and please run it. So your code will run, and then that code will uh, gather the data from various containers and get the work done. All right, or it will run the different code on different containers in various nodes at various locations. So our this is what our yarn looks like. All right. Now, a little bit about computing paradigm called MapReduce. So far, we only talked about that there is somebody who executes things for you. We did not talk about how exactly you are supposed to talk to him. You talk to him in, say, MapReduce paradigm. We will cover Spark at later point of time. But before that, I would like to cover the MapReduce. So you could talk to Jan in a in the in a paradigm called MapReduce, or you could talk to Jan in terms of Spark. Now, all right, this is how typically the MapReduce looks like. So when you are programming MapReduce, you write two logical units. One is called map. Map is a piece of code, and you write reduce. Reduce is also a piece of code. Okay? In your head, you can always imagine the map function to be something like this. Okay? So your map function, let's say, what do you call? So function, or let me just try to create some easier thing. Function, map, and input record. Okay, so this map function will take the input record, return, not return, but produce key, comma, value. Okay, and it can produce this key for value for every time. So when you are talking to MapReduce paradigm, you talk in terms of this. Here we are saying a map is taking an input record and producing a pair, a pair of key and value. Or maybe map can produce as many key value pairs as it wants. So now imagine this. There are many machines you have stored. We will continue with the same example. We have got 200 terabyte of data stored on these many nodes. Okay, stored on these many nodes. For each node, there is something called a split. Split 0, split 1, split 2. For simplicity's sake, we have only one split on one node here. But there could be multiple split on each node. Then for each node, there'll be this map unit. Now, for each split of that input data, it will run your map code. For each split, it will run your map code, and your map code will generate all kinds of key value pairs. All kinds of key value pairs map can generate. All right. So in our case of finding a particular line, the code will look like this: function, map, input record is input line. Okay, for this simplicity sake, for each line or input lines, instead of input lines, we call it list of input lines. Okay, so for each split, because your split would be around 128 MB, out of this 128 MB, you will create lines, and for each line in list of input lines, okay, for each line in list of input lines, what is it that you want to do? You want to first see if line contains, say, let's say Sahab, okay, Sahab or Sahab or Anusha. I'm just writing in a pseudo language which might look a bit like Python. Okay, so if line contains Sahab or Anusa, produce line. And since we don't want to put anything in value, we are just leaving that empty. Okay, so you can see that this is how your map code is going to run. Now, look at this here. The map code is being run on every line, right? Every section of section of the data, or every block of the data, it will run for each line and generate these results. Okay, And since in our this example, we don't need, or let's say in the output, what we want is, um, all right. So let's say in this output, what we want is we want to deduplicate the line also. We want to remove duplicate lines, or we want to count the duplicate lines. Okay. So here, each map is producing these lines and blank. Blank is the value, line, actual line is the key. And then after the map has produced, okay, after the map has produced the key value pair, there'll be a huge list of the key value pair here, huge list of key value pair here, huge list of key value pair here. Then all of that will be carried to another node. This node is also another task tracker, keep that in mind. This node is also another task tracker. On this node, what are we going to do? We are going to merge it. This is what Hadoop is doing. Hadoop is merging it. What does it mean by merging? Because these lines are getting sorted, the ordered, okay? These lines are getting ordered on each machines. So each section of the data is getting ordered on each machines. And then while merging, the ordered data is getting merged and sorted here. Sorted as in after merging, because each section is individually sorted, but overall needs to be sorted. Therefore, after merging, we need to sort it on a single node. And after sorting all the keys, uh, each key and all its values will be brought together. Okay, so all the lines who are identical, they will be gathered together. Okay, and their values will be concatenated array of array of values. Here in our case, please note that it's blank. Let's put it 1, just arbitrary, just for the heck of it. Now, your reduce function looks like this. Your reduce function looks like this. Key, comma, or you can say, yeah, key, comma, list of values. Okay? List of values. So this is how your reduce function. This is here you will write your code goes here. All right. So this is how you will write your code of reduce. Here, this is your map. All right. Don't worry if you don't know programming yet. Don't worry about it. Just focus on the idea. So think of function as a machine which takes some input, gives out some output. Similarly, map and reduce, both the things are like a machine which takes some input, gives out some output. Okay. Okay, just like any expeller or just like any juicer, it takes some input, gives the output. Okay, so these map and reduce are true sense of machines. I mean, although it's a piece of code, but they behave, every function behaves like an input output kind of machine. All right, I mean that's how most of the functional programming is designed. So you can see that reduce function will look like key and list of value. And what is this list of value? It is this. So there will be lots of times your map function is executed and key and values are gathered, sorted together, and key for a particular key, all of the values are brought together from all the node and at a single place. Now this list of value for each key has to pass through your reduce function. It's up to you what you write inside reduce function. You can comfortably say that, hey, I don't need any summarization at end of process. Okay, you might say, hey, I don't need any summarization of process here. So please store whatever is the result here into my HDFS. Okay, you can comfortably say that. But in case you want a summary, you want to combine the data together, or you want to order the data together, in those cases you need reduce function. Reduce function, it is completely up to you. And for this reduce function, MapReduce paradigm or MapReduce component of Hadoop will execute your reduce function for each key. for each key. The way map function were executed for each record in the input. Similarly, reduce will be executed for each key produced by map, just that all the values of a particular key from all the nodes will be brought together. So it's up to you what you decide as the key value in map, and it's up to you what you decide to write in reduce. Whether you want to do the summation of the values or you want to do the average, you just want to find the maximum or minimum, or you want to concatenate the values, or you want to just pick the first one and forget everything else. So it's up to you what you do want to do inside the reduce function. So all the data from all these nodes is brought to reduce, merged, sorted, and fed to the reduce, and whatever is the result of the reduce is saved to HDFS. All right? Do I make sense, Sahib? And Anusha, did I went ahead? I mean, did I went too far? Did I go too far, or are you still with me? Yes, go ahead, Sahib. Hi, Mehdi. Mehdi has also joined the session. Okay. So any questions at this point, Mehdi? Okay. Sahib's question is, if we are getting the data, so today's session is going to be a little more fast-paced, and I'm going to, all right. So this was BDA 3. Sahib's question is, if we are getting data in terabyte after reduce, how will we handle it? How will it how will we handle it? Will same as parallel computing? Okay. If you're getting terabytes of data after the reduce here, so it only means that if it only means that you need more reduces. The way you have one task which is dedicated for reduce, you can have more of such tasks. The way you can say to MapReduce engine that my reduce process is really heavy, so please create more reduces. You tell MapReduce paradigm how many reduce tasks do you want. If you want to run the same reduce process parallelly on 100 computers, you can tell MapReduce paradigm the same thing. Do I make sense? Okay. So in that case, if you are really curious to know exactly what happens, I would like to show you that. Yeah. So in that case, in case you have many reduces, this is what happens. Some part of the input data input, some of the keys go to first, some of the keys go to second. Just that one key, same key goes to the same node from all the mappers. All right? All right. Do you want me to put the diagram as well? Because that's very important diagram. All right. So, All right. So that was an overview of MapReduce. How does it work? And how does the paradigm look like? Now, what you saw just now is while on one hand, we are selecting a key, we are saying that this is my key, this is my value. And Hadoop is, you're saying something, Anusha? Because I have not put the headphone. All right. So I think all of you can just come in the panel and then you will be able to see each other. Okay? Because there are only few candidates in these sessions. It's please mute yourself. All right, I'm muting you, Mehdi, as well. Sorry, make me the presenter.